Okay, so good morning, all. So we already discussed about the logical backups. We discussed about the physical backup. In the physical backup, we discussed about the PG based backup. In the PG based backup, we seen right different options how we can take the backup, how we can do the point in time restore. Okay, so everything we covered until yesterday. Okay, and if we observed in the PG underscore base backup. Okay, so there is a disadvantage, or maybe we can say there is no option is available. Okay, to take the RMAN kind of a backup. It means the full backup, incremental backup, and differential backup. Okay, so we have only option is available to take the full backup by using the PG underscore base backup, at least for Postgres SQL 16 version. Okay, so it means there is a maybe the different topic, or maybe just for your information. Okay, so the Postgres SQL community, it is keep on working on improving each and every concept and each and every utility. Okay, as part of their research. Okay, though in Postgres SQL 17 onwards, we can say the incremental base backup option is available. Okay, the incremental base backup option is available directly from the native Postgres SQL backup utility, that is a PG underscore base backup. Okay, but until Postgres SQL 16 version, we don't have such option in Postgres SQL. So if you want to achieve, or if you want to play with the different types of backups, like full backup, incremental backup, and cumulative backup kind of option, you want to use until Postgres SQL 16 version. So you need to depending on the third-party tools or third-party utilities. Okay. So one of the the third-party utility and third-party tool it is widely using. Okay, in real-time systems, that is one of the utilities, PG and the PG backrest utility. Okay, and there is one more utility. Okay, the PG backrest is an open source utility, so it is useful to take your Postgres SQL full backup and incremental backup and cumulative backup or differential backup. Okay, based on your requirement. Okay, and apart from PG backrest, okay, we have another utility, that is the barman. Okay, so the name, it is equivalent to rman in Postgres, sorry, in Oracle. Okay, so the barman is one more utility. Okay, this one is developed by second quadrant. Okay, second quadrant organization. Okay, so the barman and backrest both are we can say it is going to provide the functionality. Okay, similarly Arman in Oracle. Okay, so the PG backrest is a completely open source tool. Okay, and it is having the MIT license. Okay, so you can download the code, you can add your things, you can deploy. Okay, you can play with source code, you can push whatever the extra code you want. Okay, so you can do the same thing after downloading the PG backrest source code. Okay, and the second quadrant one, that is the we can say that is from sorry, the barman related utility, that is from the second quadrant. Okay, so it means if you want to it is completely, we can say, the enterprise related the backup utility from the second quadrant, or EDB. Recently second quadrant is acquired by EDB, enterprise database. Okay, so if you want to have enterprise kind of support in the backup, so then to have similar features like RMAN, so PG backrest is one non-enterprise or open source utility. You want enterprise utility, you need to go with the barman. Okay, so those are the two options are widely available until Postgres SQL 16. Okay, even the similar kind of, as we said, okay, at the similar kind of functionality, you can get it with PG base backup only from Postgres SQL 17. The information is already published. Okay, the PG base backup is going to have the incremental features in Postgres SQL 17. Okay, but until now, so the PG backrest and barman is the two utilities are widely using in the market to have the backup strategies. in the real-time systems. Okay, so today like what we can cover is like we are going to cover about a a backrest utility, and we are not going to cover barman. Okay, but we can give the the content. Okay, the lab steps, how we can execute the barman. Okay, how we can configure and everything. We are going to give the barman related documentation for you. Okay, you guys can practice. Okay, so we can start with the PG backrest utility. So this is an open source physical backup tool. Okay, so under the like MIT license. Okay, so the actually with the help of the PG backrest, okay, we can automate your physical backups, and also so archive also. You can take like these physical backups locally. You can take it, and also you can take even the physical backups and wall files into even remotely also we can take it. It means we are going to have a separate server. Okay, for a PG backrest utility. Okay, there you can maintain everything. You can maintain physical backups, and you can maintain the all the wall files into that physical sorry, into that separate server. Okay, it means we are having the separate repository for this backup solution. Okay, and we can have different clusters related backup into the same repository. Okay, so it means here you can say the locally or remotely. It means locally means you can install the PG backrest on the same system which is the database cluster, PostgreSQL database cluster is running. Okay, you can install the PG backrest utility on the same system, and you can take the backup into the same system. Okay, and there is an option also like we can take the same thing on remotely also. So while you're taking the remotely, so you need to have, okay, in the remote system, just you need to have the PostgreSQL client. On top of PostgreSQL client, you need to install the PG backrest utility. Okay, and there are some settings like we need to have the SSH connectivity. Okay, and passwordless that passwordless connectivity. So then we are able to have this remote repository to take the backup of your source system, the production systems. Okay, so the main advantage with the PG backrest utility is, okay, if compared with the PG base backup. Okay, so we can take full backup, we can take differential backup, and we can take incremental backup also. But until, as I said, okay, until PostgreSQL 16, we don't have such options with PG underscore base backup from community version of the PostgreSQL. Okay, to achieve this kind of options in the backup, to have this kind of backup strategy in our systems. Okay, so I need to use the PG backrest utilities to support full and differential and incremental level of the backup. Okay, so and also the PG backrest utility, it is going to support the parallel options to get maximum speed while taking your backup of your PostgreSQL cluster. Okay, so and also as we said in the first point, okay, so we can take the PG backrest. Okay, we can take the backup of our PostgreSQL cluster with help of the PG backrest utility. Okay, you can take locally or you can use any standby server to take the backup. Why? Because so if you plan to take the standby server, it means there is no burden or there is no a resource consumption during the PG backrest utility to take the backups. Okay, so if you have the standby server, okay, you can configure. Okay, you can configure a backup for the standby server. So if the standby server maybe the which level of replication you're using. Okay, we will discuss in our next sessions. Okay, how many types of replication options we have. Okay, so based on the streaming replication or logical replication, if you have a standby setup, okay, so you can take based on the log level. So which level of log you are wall logs you are doing replication to minimize the lag between the primary and the standby. Okay, so then you can utilize even standby servers to take the backup just to offload your resource consumption on your source production system. Okay, So this is also possible by using the PG backrest utility. Okay, so exactly PG backrest utility. So while using in the PostgreSQL cluster, okay, so there is an option like push and pull for the wall files. Okay, so it means we can push while generating the walls itself. Okay, we can push the same wall files into a backup repository. Okay, and also we can sit on the backup repository server, and we can pull the wall files directly from PostgreSQL live system to, okay, the backup repository location. Okay, so in this can be like asynchronous mode. Okay, this backup push and pull, we can get it from asynchronous mode to improve the performance of your wall movement. Okay, from source to target, or from you are sitting on the repository location and you want to pull the wall files from source into the repository server. Okay, so that can be possible. Okay, this is directly or indirectly it is going to improve the performance. Okay, why because suppose if you store your wall files into your production system itself, okay, then while you are taking the backup, or while you are like maybe performing the recovery operation, okay, restore and recovery operation, so there may be like huge amount of wall files in place in of your source system. Okay, and you are planning to restore. Okay, you are planning to restore and recovery into different machine. Okay, in the situation, okay, we need to copy all these files from your source system to your target system, or maybe we can your restoring system. Okay, so it may be like some time consuming. Okay, but while creating or while generating wall itself, we have if we have an option to push that wall files directly into your backup repository. May anything repository, maybe it is created locally into your like live system, or you can create remotely, okay, into some different system as well. Okay, but this if you are like using the like a remote repository, then the wall push and pull will be generated or transferred in a synchronous manner. Okay, it is going to improve the performance, okay, of the PG backrest utility. Okay, and one more thing is the PG backrest is not going to use, okay, not going to use the database catalog views, or the database catalog to list your available backups in the database cluster. Okay, so the PG backrest repository, okay, the PG backrest repository having enough information. Okay, so if you take the continuous backup, either full, incremental, differential, and multiple level of backups, if you take it, okay, so that all the information will be available. Okay, all the information will be available in the backup repository. Okay, so that the information is enough to restore your PostgreSQL cluster. Okay, so that is the one, we can say the info for you guys. Okay, so we no need to have like a database catalog views to maintain the backup information. Okay, the PG backrest repository is more than enough to perform, okay, to perform the restore operation with help of the PG backrest utility. Okay, and one more thing, the PG backrest repository can be anything. Okay, it means we can maintain the repository in the same live system. Okay, and we can use any NFS file system or CFS file system to have the PG backrest repository. And also if you are playing, okay, if you are playing you can say you are using the cheap storage from the any cloud vendor. Okay, so in the situation the PG backrest, you can have the repository into any cloud storage. Okay, either it may be S3 buckets from the AWS. Okay, either you can use cloud storage from the GCP, or maybe similar storage solution from the Azure and OCI. Okay, so based on your requirement, even the PG backrest is compatible to have the repository on like top of any cloud storage as well. Okay, so we have the different kind of options, okay, based on your requirement and based on your like availability of the storage. Okay, you can pick any NFS or any cloud related storage to store your repository information. Okay, any doubts with this slide?
I'm okay.
You were able to see my screen, just I slide, I jump into next slide. PG backrest backup types.
Yeah.
Okay. Yeah, so these are the, like we can say, these are the backup types we have in the PG backrest utility. Okay, so so we have the like three three types of backups. Okay, one is the full backup, and second one is the differential backups. Third one is the incremental backup. This is equivalent. Okay, this is equivalent to our Oracle RMAN backups. Okay, so the full backup, okay, the full backup is like it is going to take the entire PostgreSQL cluster backup. Okay, and so whenever if you are taking your PostgreSQL cluster backup, okay, first time, okay, by default it is going to take the full backup, okay, with help of the PG backrest utility. Okay, and also, so you are restoring, okay, you are restoring and recovering your system. Okay, the full backup is the base backup for your restore and recovery operation. Okay, if you have the full backup in place for your PostgreSQL cluster, okay, while you are restoring your system, okay, your PostgreSQL cluster, either in place restore or maybe into like a different a destination server restore. Okay, so what we can do, so we can utilize, okay, we can utilize the full backup. Okay, on top of the full backup, if you have any changes, okay, those changes will be available into WAL files. Okay, so it means the full backup plus WAL files, you can restore and recover your PostgreSQL database cluster, either into the in place restore or either into like a different server or different into the different system as well. Okay, and second one is like differential backup. Okay, differential backup. Okay, so with help of the PG backrest utility, okay, what it will do, it will take, okay, what are the changes are happening, okay, what are the changes are happened, or what are the changes happened after the like last full backup. Okay, those all the changes will be captured, okay, while you are taking the differential backup. Okay, okay, the main advantage of the differential backup is, okay, so compared to the full backup, it is going to store, or it is going to occupy very less storage, okay, as compared with the full backup. Why because during the differential backup, we are taking only the changes after our full backup. Okay, so it means differential backup, definitely it is having, or it is occupied very less storage compared to full backup. Okay, so to restore your PostgreSQL cluster, okay, you have full backup and you have the like differential backup. Okay, to restore your database cluster, then how we need full backup and also we need differential backup. Okay, so on top of that, suppose is there any changes, okay, is there any changes is happened after the differential backup, it means full backup, differential backup plus after WAL files, okay, or log files. Okay, then you will get the consistency of your like a database after restoring into either local system or remote system. Okay, and then next one is like incremental backup. Okay, so incremental backup means actually the base backup for incremental is the previous backup is anything. It means the previous backup, it might be like any full backup, it may be differential backup, it may be incremental backup. Okay, so during the incremental backup with PG backrest utility, what it will do, it will take, okay, it will take what are the changes happen from the last backup. Okay, and the last backup can be anything. Last backup may be like full backup, last backup may be like differential, or last backup may be the incremental backup. Okay, so compared to full backup and differential backup, okay, incremental backup will occupied, okay, incremental backup will like use the storage. Okay, this is very less storage we can occupy whenever if you take the incremental backup. Why because it is taking only after last backup changes. Okay, it means suppose differential backup is depending only on the full backup. Okay, and incremental backup is like depending on any last backup. Okay, so compared to differential backup, incremental backup is taking less storage. Okay, and compared to full backup, differential backup is taking or like using the less space in the like your repository to store incremental backup related backup pieces. Okay, and to restore your database, so you to restore your database after incremental backup, so always incremental and differential backup is depending on the base backup, that is the full backup is the base backup to restore your database cluster. Okay, so then in between there is a differential backup, so then full backup plus differential backup. Okay, then after the differential backup, so you need to depending on like how many incremental backups you have. Okay, that incremental backups you need to utilize or you need to use to restore your PostgreSQL cluster with help of the PG backrest utility to make the data consistency always. Okay, always like if we have any backup in your place. Okay, so you should definitely depending on your backup plus wall logs or arc logs, then only you will get like data consistency after your restore operation is completed. Okay, so this is the known things, guys. This is almost similar. Okay, this is almost similar to your like Oracle RMAN. Okay, RMAN also we have the full backup, we have the differential backup, we have the incremental backup. Even RMAN also differential backup is nothing but after full backup changes will be like stored into one differential backup. Okay, and incremental backup means either it may be a base backup is either it may be incremental, either it may be differential, either it may be the full backup. Okay, after those backup changes will be stored into the incremental backup. Okay, this is a known fact since you guys are already working on a Oracle. Okay, this is the known thing for you guys. Any doubts here?
We need the archeolog backups also to get in point in time recovery, right?
Yes, exactly. See, during the backup, okay, during the backup, so it is included into, we can say, the backup. Okay, archaeologs is like included into backup, but we don't have any separate concept like take the only archeolog backups in PostgreSQL like Oracle. So Oracle we can take, right, archeolog backups. Okay, so we don't have such option here in PostgreSQL. Okay, archeologs are coming. Okay, so if we take the full backup in Oracle, okay, plus archeolog all, okay, then full backup means all the data files plus archeolog backup will take it in Oracle. Okay, and if you want to take separate archeolog backups also, you can take the archeolog backups in Oracle, but we don't have such option in PostgreSQL to take only archeolog or like wall backups. Okay, so you need to depending on wall files or archeolog files plus what is the backup you have to make the data consistency. Hope it is clear for you, Malati.
Okay.
Okay, yeah. Okay, so this is the PG backrest terminology. We can say while we are playing with the PG backrest, so the name Stanja, okay, this is a unique name and this is the main thing in the PG backrest. Okay, maybe we can say this is the like core file or maybe it is containing each and every configuration related information. Okay, to perform the PG backrest utility. Okay, to perform the backups with help of the PG backrest utility. Okay, first of all, what is a Stanja? Okay, this is a configuration file. We can say this is a configuration file, or maybe this is a configuration for our PostgreSQL database cluster. Okay, so in the Stanja, so what we need to give the details are like we can create, okay, where the PostgreSQL cluster is located. Okay, we are going to perform, we are going to we are going to create and we are going to place, okay, where the PostgreSQL database cluster is located. We are giving the location of the data directory of your PostgreSQL cluster in the Stanja. Okay, and also we are going to like define, okay, how we are going to take the backup. Okay, so those information also we are going to provide in the Stanja. Okay, and also the different types of archeolog options. Okay, which type of archeolog options you are using. Okay, those information also containing in the Stanja. okay, and we have like which level of like logging you are going to perform and you are going to enabling for your backup, okay, and those information also you can get it with the stanza. Okay, we will show you, you will get the better understanding while we are like discussing about the a demo. Okay, so what are the different options are available in the stanza. Okay, suppose if you are playing with like the remote machines, okay, in the remote machines like we need to provide the remote host details and the port numbers, okay, and everything we need to mention in the stanza file. Okay, it is kind of like some configuration file, we can say. With the help of the configuration file we are going to create the stanza, okay, that we will show you, you will get the better understanding. Okay, in the stanza, so even suppose you are playing, okay, you are playing with SSL certificate. Suppose my system is like highly encrypted, okay, and it is having SSL certificates also, okay. So in this situation you can mention all those details into the configuration files and you can create the stanza for that. Okay, maybe in the direct word, in the simple word we can say, okay, the stanza, okay, the stanza is nothing but it is containing the all the configuration details of your PostgreSQL database cluster. Okay, so based on the stanza only, okay, the based on the stanza only, so the PG backrest utility will perform your backups of your PostgreSQL cluster, okay, based on the configuration parameters you provide into the configuration file, okay, in the stanza. Okay, so that we will show you. Okay, and next thing is, okay, so the next and main thing is, while you are like creating a PostgreSQL configuration file and while you are creating the stanza with help of the like PostgreSQL conf file, okay, the PG backrest conf file, not Postgres, sorry, okay, PG backrest conf file. So there we need to mention, PG and PG underscore path. That is the one parameter. Okay, that parameter is very important. Okay, so this parameter we are referring, okay, we are referring what is your stanza, okay, for our PostgreSQL cluster. Okay, it means here we are going to provide, okay, the location of your PostgreSQL data directory. Okay, suppose you may have a doubt, okay, you may have a doubt, okay, so it's the stanza is for each PostgreSQL cluster. Okay, the stanza is for each PostgreSQL cluster. Suppose I'm planning, okay, I'm planning to have, suppose multiple PostgreSQL clusters are available. Okay, suppose I have PostgreSQL 14, I have PostgreSQL 15, and I have PostgreSQL 12, and also I have different like servers and different PostgreSQL same versions of the like PostgreSQL clusters are available. Okay, so in this situation, how we can play with the stanzas. Okay, in this situation you can create multiple stanzas for each your PostgreSQL cluster. Okay, multiple stanzas for each your PostgreSQL cluster. Okay, and you can take your backup. Okay, you can take your backup by specifying the stanza name. Okay, so maybe let me share my screen with the paint. Okay, you will get the better understanding. Let me share it. Okay, here. Okay, are you able to see my screen?
Yes.
Okay. Okay, suppose I can say this is my source system. Okay, and I can say, okay, so suppose I can say this is my source DB. Okay, So the PG backrest, we can use, we can use the PG backrest on top of your PostgreSQL source database. Okay, so it means we can install PG backrest here, PG back backrest here. Okay, and we can maintain the PG backrest repository in the same source system. Okay, if you don't have any separate servers and there is a maybe constraints related to the cost. Okay, you want to have sufficient resources on your source DB. Okay, so you can install your PostgreSQL source DB to have the PG backrest. Okay, so in the situation, you can have the PG backrest software in our same system. Okay, and you can install it and you can make it as the repository. Okay, so this is the one way. And suppose your source DB is having TBs of size. Okay, so TBs of size and you don't have sufficient storage. Okay, suppose my backup strategy in our organization. Okay, I can say, okay, 7 days. Okay, 7 days is my the backup retention. Okay, and in this situation, okay, so what I am planning, so I need to have every Sunday. Okay, every Sunday full backup. Okay, and then maybe Wednesday, okay, I'm taking a differential backup. Okay, and remaining all days I'm taking incremental backup. Okay, so in this situation, if you say the full backup, it is maybe the size of my database is suppose 30 TB. Okay, so 30 TB is my size. Okay, to even if you use the compression. Okay, if you use the maximum level of the compression also. Okay, if you take the full backup, at least it will occupy 10 to 15 TB of your storage. Okay, so okay, and on top of that, suppose based on your retention. Okay, based on your retention. Okay, and based on your the cleanup strategy, how you are maintaining. Okay, so you need to have at least 20 TB or maybe 30 TB of storage to maintain the backup. Okay, and also the backup is maybe into the different file system in your source system. Okay, and it is containing or maybe it is shareable for any data location. Okay, it is shareable for any data location for your PostgreSQL cluster. Okay, then it is directly or indirectly affecting your PostgreSQL system performance. Okay, and PostgreSQL that may be some bottleneck in our in place PG backrest repository. But you can have options. Okay, you can have an option in PG backrest. Okay, so you can utilize. Okay, you can utilize different repository. Okay, you can utilize different repository into the different location or different host system. Okay, so in this situation, what you need to do. Okay, so you need to install the PostgreSQL client, PSQL client. You need to install into the your repository. Okay, different server. Okay, and then you need to install the PG backrest. Okay, on top of your new system, or maybe we can say the repository system. Okay, and here you need to enable the SSH connectivity between your source system and the target system. Okay, and here you need to create. Okay, you need to create stanza. Okay, in the stanza, what it is having, the stanza is having the details about your source system. Okay, so here we need to have suppose my PG1. Okay, so PG1 related data directory. Okay, data directory, and also it is having. Okay, it is having the port. Okay, so it is having the port by default port is 5432. Okay, like that we can create the PG backrest repository while you are taking or while you are having separate a repository for your PostgreSQL cluster. Okay, so the benefit of this particular PostgreSQL PG backrest utility to have the separate system is, okay, we can take the advantage. Okay, so you can include not only for single instance related backup into the repository. Okay, so you can even integrate or you can take the backup and you can utilize the same repository for n number of PostgreSQL instances. Okay, PostgreSQL clusters. In this situation, what you need to do. Okay, so you need to create separate stanza. Okay, separate stanza for suppose we need to create stanza. okay, standard 2, then the PG2, okay, the data, okay. So then we need to mention the data directory for our maybe this particular instance, okay. Then you need to define or you need to segregate with port number. Okay, so in this situation, only thing is, okay, you need to separate, okay, you need to separate with a different port number, okay. Even the same port number also fine, but that is not a problem. But two stanzas should not be used, and two stanzas should not be like scheduled at the same time, okay. It is going to create the conflict while you are taking the backup, okay. In the same, but the better approach is you need to have the different port numbers, okay, for different target systems, okay, to have the common repository, okay. And the main advantage of like having the like common repository for different systems are, okay, so it is like it is not included as part of your live system, okay. It is just behind your live system, okay. And it is not utilizing, okay, it is not utilizing directly or indirectly of your PostgreSQL system resources, okay. It means during the backup utility, okay, during the backup utility or during the backup running, okay, there is no effect for your live system, okay. There is no effect for your live system, okay. The PG backrest, okay, the PG backrest, what it will take, okay, it will take the backup at the block level, okay. So it will copy the backup at the block level, okay. So the system resources also, the utilization of the system resources of the, like we can say minimal, okay. We can say the minimal if you are using the PG backrest hub, okay, behind your live system, okay. And another advantage, as we discussed, okay, we can, if we have the like a backrest PG backrest hub in place, okay, in your system, okay, then you can integrate all your PostgreSQL clusters into this backup repository, okay, or backup hub, okay. And only thing is, while creating the stanzas, you should be careful, okay, by separating data directories and the port numbers for your different target systems, okay. Then you can play and you can have your like one common PostgreSQL repository for all your PostgreSQL clusters, okay. And just you can maintain the enough storage into the particular repository system, and then it will be like work very seamlessly and offload almost all your like live system resources usage, okay, while taking the backups, okay. So this is any doubts here, guys? Okay, silence, no doubts. Okay, let me share my screen again for slides. Okay, so this is the way we can create like stanza, okay. So we are going to use like PG backrest utility, okay, the PG backrest utility, and we need to give the stanza name hyphen stanza, okay. The demo, okay, this is the like name of the stanza, okay. So how the like stanza file will be created, how the like pg backrest.conf file, okay. Under the pg backrest.conf file, we need to mention and we need to create all the stanza related settings, okay. It is containing the two parts. One is like global related parameters, and second one is like stanza related parameters, that you will get the better understanding in the like demos, okay. And the next one is like we need to mention like log level console, okay. So it is having the different types of options. We have info is the one of the option, errors we have, warnings we have, no log we have, okay. So it means the log level console means it is going to provide like during the like the creation of stanza, taking the backup of your database cluster, okay. We are going to mention the log level console equal to info, or log level file equal to info, or error or anything, okay, based on the log level here mentioning, okay. So this will be generated, okay. The log will be generated on the screen, okay. And also the log will be generated on the provided log location while you are initializing your PostgreSQL stanza, okay, by using the PG backrest utility, okay. then we need to have like stanza hyphen create. Okay, with help of this stanza create utility or option, okay, we can create the stanza. Okay, and this stanza is like referring to the like PostgreSQL, sorry, the pg-backrest.conf file. Okay, we will show you in the demo. So based on that conf file, okay, the backrest conf file, okay, the stanza will be created. Okay, if you see here, the pg backrest file is containing these kind of like settings. Okay, log level console, log level stdr, okay, no log timestamp, okay, and the pg1 path. Okay, this is the path of your stanza PostgreSQL directory. Okay, so in the inside the stanza, okay, we can create the stanza name. Okay, we can create the stanza name. Under the stanza name, we need to mention the data directory of your PostgreSQL cluster. Okay, this is equivalent. Okay, this is equivalent to data directory location of your PostgreSQL.conf file. Okay, so we should be very careful. We need to mention proper directory location to take the backup of your PostgreSQL cluster. Okay, and we have different options also we have in the PostgreSQL sorry, pg-backrest.conf. Okay, that we will show you. Okay, how we need to mention during our demo classes. Okay, and these are the features we have in the PG backrest utility. If you are using the PG backrest utility, so these are the options we can have. Okay, so the first option, that is we know. Okay, it is going to support. Okay, it is going to support full incremental and differential backup. Okay, that feature is not directly available from the native or vanilla flavor of the PostgreSQL cluster. Okay, this option is not available. And we have like parallel option. Okay, we have like parallel option in PG backrest utility. Okay, so you know, right, so whenever if you're performing any compression while using the while taking the backup, okay, definitely it is taking a long time while compressing your backup while taking backup itself. Okay, so to avoid the situation, you can use the parallel backup and parallel restore operation to speed up your compression during the backup. Okay, so it means the parallel option is available in the PG backrest utility to take the backup and to restore to perform the restore operation as well. And the next one is we can take the backups locally or remotely. Okay, by using the PG backrest utility. Okay, so the only thing is if you are taking the backup at remotely, so you need to have the TLS or SSH connectivity. So password is connectivity to take seamless backup from the remotely. Okay, and the next thing is like if you want to have like multiple repositories. Okay, there is an option in PostgreSQL with the PG backrest. You can have the multiple repositories. Suppose I have a maybe I'm dealing with huge amount of databases. Okay, I'm dealing with huge amount of the databases. Okay, so then in the situation, so maybe I can do the multiple repositories. Like I can have the local repository, one copy of the local repository, and also I'm going to have multiple copies of my backups into my remote repository. Okay, so while restoring, if I'm having the local repository, means while restoring the backups from the huge amount of the backup pieces, so then it will be very easy. But again, there is a disadvantage. Okay, if you are storing that much of amount into your local system, it is consuming the space and also the resource. Okay, the resource it is consuming, and is one more disadvantage if you are taking a backup locally. Okay, but the thing is, whenever if you store, okay, whenever if you're maintaining the local repository, then the restore operation, okay, the restore operation is it is very fast. Okay, why because if you're storing in remotely, then you need to copy all your backup files into your the preferred location. Okay, so the copying itself, it is taking the long time. But so as we said, the multiple repositories options are available. Okay, based on your use case. Okay, you can have the local repository, and also you can have remote repository as well. Okay, Okay, and next thing is like backup rotation and backup archive expiration. Okay, so backup rotation is like based on your backup strategy. Okay, based on your backup strategy. So those backups will be like automatically rotated. Like it may be like expired and absolute. So those backup will be deleted. Okay, based on your the schedule. Okay, how you are going to have in our PG backrest. Okay, so then next thing is the backup integrity. Okay, this is a important topic we can say. Okay, so backup integrity with PG backrest in PostgreSQL, it is performing. Okay, it is performing with help of the checksums. Okay, PG checksums. Okay, so what it will do while taking the backup. Okay, or while performing the backup restoration. Okay, the checksum PG checksum will calculate, okay, every file, and it will validate each and every file. Okay, so the backup file is like valid or not. Okay, it is having, okay, it is having any corrupted blocks. Okay, corrupted blocks are there inside the file. Okay, everything will be checked, okay, during the restore operation. Okay, and also whenever if you are performing any backups. Okay, so what it will do, it will take the backup, and also it is also going to check, okay, in which level, okay, in which wall level it is containing the backups. Okay, so to maintain the just data consistency. Okay, to maintain the data consistency. Okay, the with help of the PG checksum. Okay, in the PG checksum, by using the PG checksum utility. Okay, it is going to validate. Okay, it is going to validate the backup is consistent or not. Okay, so that is useful whenever if you are going to perform the restore operation with help of the same backup. Okay, so and next thing is like PG checksums. Okay, the PG checksums here is it is going to validate is there any backups, sorry, is there any blocks are corrupted. Okay, while taking the backup, so it is going to validate each and everything. Okay, so if they found is there any corrupted block while taking the backup. Okay, there is no capable of to repair those particular particular block, corrupted blocks. Okay, with help of the PG checksum, the continuity of the backup. Okay, so the continuity backup will be there. Okay, it is simply skip those corrupted blocks. Okay, it is simply skip that corrupted blocks, and backup will be like in progress. Okay, so that is the main use of the checksum. Okay, and the next thing is backup underscore resume. Okay, so it means suppose due to some abnormality, okay, the backup is stopped. Okay, so then the PG backrest having the capability, okay, by using the PG checksums. Okay, the PG checksums is containing up to what level. Okay, so up to what level or up to what block level the backup is completed. Okay, so it will compare, okay, the backup location and also the location of the source database. Okay, it will compare at the block level. Okay, and we can able to resume your PostgreSQL backup. Okay, with help of the PG backrest utility. Okay, inside this resume operation, it is depending on the PG page checksums utility. Okay, so it is containing until which block we took the backup. Okay, and where is the backup pieces are loaded. Okay, it will compare the the taken backup, and also it is compared with the available backup ready for the ready to take the backup. Okay, it will compare those things. Okay, and what are the backup is what are the changes happen after the backup. Okay, or when the backup is started, after those data will be easily taken with help of the PG backrest utility. It means resume option is also available here in the PostgreSQL. Okay, and one more thing is delta restore. Okay, so the delta restore is nothing but suppose if we restore your PostgreSQL cluster with help of the delta restore. Okay, so it is very fast, we can say. Okay, it is very fast, we can say. It means what it will do during the delta restore with help of the PG backrest utility in a PostgreSQL cluster, it will just skip, or it will do the restore operation only for the the blocks which are not available into your PostgreSQL cluster. Suppose I have the PostgreSQL cluster, okay, until maybe yesterday my data is available, okay. So then I need to only restore, okay. I need to only restore what are the changes happened after yesterday backup, okay. So in this situation, if you use the restore operation with the delta option, okay, then what it will do, it will simply skip, okay. It is not going to see whenever there is a restore operation you are performing, okay. So the restore operation, definitely you need to use the base backup is a full backup. On top of the base backup, you need to have like incremental or differential backup plus archaeolog files, okay. But if you use the delta operation in the PostgreSQL with help of the PG backrest utility, okay, what it will do, it will just restore what are the like changes or what are the like available blocks, okay, after our existing the backup latest backup restore, okay. It means we can say in the simple word, it will restore only the files or blocks is required to make the database into the consistency mode, okay. Only those blocks will be restored, okay, and it will perform the recovery operation with help of the delta restore instead of restoring from the base backup, means full backup, okay. That option also available in the like PG backrest utility, okay. And a table space link options also available, remap table spaces, and the link options. Link option is nothing but if your source system is having like some soft links between the like different locations for their customized table spaces, okay, even that options also available. To the same links we can use to perform the restore operations, okay. We can mention the link option on the table space remap options we can use, and we can do the restore operations, okay. And the next thing is like we can have like a different repository options, okay. We can play with the S3 repository, S3 like storage from the AWS, okay. And we can use even Azure storage also. We can use Google Compute storage, okay. Okay, so Google Compute storage also we can use as a like a repository for PG backrest, okay. And one more thing, the encryption, okay. The encryption, even if you want to secure your backup files, okay, if you want to secure your backup files, okay, even you can perform the like encryption as well on top of your all your backup files, okay. That option also available in PG backrest utility, okay. So yeah, so those are the things, guys. So the features of PG backrest in the PostgreSQL. Okay. So yeah, any doubts, guys? So maybe we can start the like demo in tomorrow class. Any doubts, Banu, Darpan, Malati, Sadan?
So this PG backrest, it's used extensively in the live production systems?
Yes.
Or?
Yeah. Exactly. The PG backrest and Barman is the two utilities are using very widely in the environment, like live environments.
Okay.
Yeah.
So this backup that gets created, this is a different format. Like when you mentioned yesterday with base backup, we have two options like plain mode or tar
Yeah, the same.
mode.
The
So
same.
if you have tar, I think we don't have to manually create custom table space related file system and all that.
Correct.
So with the PG backrest, what is the format of the output? Or
It is actually the PG based backup, even the customized table spaces, right? Okay, the customized table spaces also we can use the remap utility, okay, remap and link utilities to simulate, okay, the same kind of the structure in our the target system, okay. But we have the same option here in the PG backrest also, okay. Like we can take like tar format, we can take the plain format as well, okay. But while using PG backrest utility own capabilities like remap underscore table space and the link options, okay. So we can directly remap, okay. We can directly remap our source system, customized table space location into the, if it is the same system, okay, that is not a problem. If it is into different system, we can use the remap underscore table space, or we can use the link option to utilize those capabilities in the PG backrest. Okay, that we will see in the like our demos in tomorrow. How it will be.
Okay. Thank you.
Yeah. Yeah. Any doubts? Any other doubts? Okay, so if there is no doubts, then we can just close the session for today, and we can have a nice demo tomorrow, okay, related to PG-based backup. And this is like very much useful in our real-time systems, okay. So as we promised, even during the demos as well, okay, either PG-based backup and barman, one we can cover and one we can give the like a document, okay. So that is the reason we are going to give the like content for or maybe the demo for PG backrest utility, okay, and we will provide nice document for barman, okay. So it is like if you like practice the barman, backrest, okay, that is almost similar related to barman, okay. So but these two things, I can say these two things are very much useful, and these two things are like utilities are using in real-time system for their backup strategies. Almost every like organization. Okay.
Right. One question. Have you covered barman in any of your sessions before?
Barman, not with these batches. Okay, we covered in some other institutes. Okay, so maybe yeah, if you find okay, we need to see our hard disk. Okay, if we have those things content, just the demo, we will share with you. But I think the document is enough that one for you to yeah practice those things. Okay, but we will see. Okay, not for these batches. I don't know, like maybe. We covered almost many batches. Okay, we will see. Okay, we will see. Not with Skyhoops, with some other institutes. We covered barman. We'll check it. If we have the videos, definitely we will share with you guys.
Yeah, that should help.
Yep.
Thank you.
Okay, so if there is no doubts, we can close. Yeah, Malati, do you have anything?
No, thank you. I'm good.
Okay. Okay, then, yeah. Thank you, guys. We can meet same time and tomorrow.
Sure. Thank you.
Thanks. Bye-bye.